remember what we said about horizontal formulas. Horizontal formulas allow us to define arithmetic, or other expressions, which include conditions that are any valid logical expression. The attribute that we define as a formula can be assigned several expressions, and the first one for which the condition is met will be executed. The rest will not be evaluated. We can also use otherwise to assign a default expression, which will be executed if none of the other defined conditions are met. The attributes involved in the formula definition must belong to the extended table of the table associated with the formula attribute. These formulas are called horizontal because when they're executed, they access a single record of the base table, and occasionally, those related records belonging to the extended table. Here we see the general syntax of the formula. Expressions can contain attributes belonging to the extended table of the table associated with the attribute being defined as a formula. Constants, predefined variables, functions, and arithmetic operators, such as addition, subtraction, multiplication, division, or power, string operators, such as plus, and date operators, such as plus and minus. They can also contain an invocation to a procedure object that returns a value. The result, either of the expressions or the one returned by the invoked procedure, must be of the same data type as that of the attribute being defined as a formula. Conditions are any valid logical expression and may contain attributes belonging to the extended table of the table associated with the attribute being defined as a formula, constants, functions, and logical operators, and or not. And comparison operators, such as greater than or equal to, less than or equal to, and like. The first condition that evaluates to true will cause the result of the formula to be that of the expression to the left of that condition, and the others will not continue to be evaluated. As we said, horizontal formulas can include in their expressions the invocation to a procedure object that returns a value of the data type of the formula attribute. For example, we define in our application a flight instance transaction. Unlike the flight transaction, where we define a flight in a generic way, with origin, destination, seats, and a base price, the flight instance transaction allows us to model a particular flight instance. In other words, a flight departing on a certain date with a flight number and with a cost that depends, for example, on the number of passengers on that particular flight. Consider the flight instance price attribute belonging to the flight instance transaction, which could be defined as a formula attribute that invokes a procedure that returns the price value of the flight instance, calculating the corresponding discounts based on the price of the flight and the number of passengers. In the parm rule of the procedure, we see the parameters received, flight ID and flight instance number of passengers, and the value returned in the variable flight instance price. In the source, we can see how the price calculation is performed. If we analyze the implemented code, we see that we could have included the same thing in the global formula without having used a procedure. We can see that the formula definition contains the invocation to the flight price calculator procedure, sending it as parameters the flight identifier and the number of passengers. Note that in this case, the horizontal formula expression only contains the procedure call, but it could include other expressions and conditions. Horizontal formulas can be global, as we've seen, but also inline. This could be the case if, for some reason, we don't want the flight instance price attribute to be a formula, but rather an ordinary secondary attribute. But then we want to run a procedure that assigns a value to it for all flight instance records. The attribute that receives the calculation, flight instance price, is not a formula attribute, but the calculation is assigned only in the source of the procedure. Horizontal formulas, both global and inline, in order to make sense, always have a context. In the case of horizontal inline formulas, the context is given by the place where the formula was defined, for example, within a for each command. In this case, the context would be the base table of the for each, flight instance, and its extended table. In the case of global formulas, the context is given by the transaction where the formula was defined, namely the extended table of its base table. In the example we saw, shown below, it's the extended table of the flight table. The context ensures that all attributes that are part of the formula can be instantiated. In the following videos, we'll see other types of formulas.